In this video, I'm going to talk about Lab 2 Exercise A, which is the first exercise in Lab 2 in CIS18A. We are creating a program that's going to compute the distance from the listener to where the lightning actually strike. And given that the listener actually heard the sound at 7.2 seconds, and then the rate is 1100. So here I have the block comment. So we would start with the /* to start our comment. And comment simply is a way that we would make note of our program or anything that you want to include. But the compiler is going to ignore those lines and not include it as code. So we want to use the / and asterisk to begin our block comment. And then we would close it with the asterisk /. On the next line, we have the class, and we declare our class as sound. This is important to remember as we talk about this in Unit 1. The name of your class needs to be matching or exactly the same as your file name, because as you use the JDK to compile your program, once you issue the command javac and then your file.java, it will create a class object, which is what you see as the second file that's in the location where you originally saved the code itself. So here we have the class sound, and I would start the curly brace to indicate that it's going to include the content of the classes here. Public static void main, this is the main function. We need a main function in order for the program to execute. And then we declare dist variable as the data type double. And you want to use double here because that way we can store larger number values at that location for that variable. Or if we're handling decimal. So decimal we can use double or we can use float, but often you would see that we can use double. And in chapter 1 it talked about typecasting, why the data type is important. And in Java it's important that we would start with the type of the data and then the variable name. And we would include the semicolon at the end, so that way it knows that we finished that line. Then once we declare the variable dist, we would go ahead and assign it the value. And in this case, we say that dist is 7.2 times 1100. And the 7.2 is given to us in the problem, and 1100 is given to us in the problem. So we use the asterisk as the multiplication, and we finish that line with a semicolon. On the next line, we do the system out print line. This tells the RE and the SE, the Java RE and SE, that we will output text, right? So we would print this line along with including the value for that variable dist. Whatever the calculation, the result here, it's going to bring that value down here. In addition to, right, we're going to have additional text that's going to be printed, right, feet away. So we have toString, and in the middle of the toString in between, we have the value from this variable. And we would include all of these things inside our parentheses. Finish that line out with the semicolon, close the curly brace. Then we can go ahead and click File, Save As. And here, point to your desktop. If you create another folder, you can point to that folder to save your file. However, in your command line, make sure that you change your directory, which is CD, to that particular location for to access your Java file. So here I want to change it to all file types. And I want to say this is sound.java. And we're going to go ahead and click Save. And since I already created one, I'm going to go ahead and override it. So once I save it, I can go to my command line and I can go to the directory, which is CD desktop. So here, notice that the path shows that I'm in the current desktop directory. Then I can go ahead and type in Java C. I want to compile the file called sound.java. And if you receive the error, it shows with the little caret. So make sure that you look at that line in your text editor, fix the syntax error, right, or the error in your code, resave it, and then recompile it. So after you edit your code, you have to resave and you have to recompile. So here I didn't receive any errors, so I'm going to go ahead and run the file now. And to run, we would do Java sound. And notice that I don't include the file extension when I run because it already created the object file, and when it creates that .class file, it's going to use that file to be able to run the program, right? So the virtual machine is going to be able to access that particular file, which is the sound.class, to be able to give you the output. So here we would do a Java sound, and I could see that this is the output that I intended for the program to do. Okay. Now what we can also do is we can edit the program a little bit. We can, instead of using the numbers like this, we can assign a variable with that value and assign another variable with the 1100 value. So here what we can do is you can have double this comma, and we can say we're going to use time for 7.2 and rate for 1100. And then what we can do is down here, we can assign it that your time is equal to 7.2 and rate is equal to 1100. So we simply replace the value with the variable as we assign it already a value there. So we can say it's going to be equal to time, multiply it by rate. Okay, so as I edited this program, I'm going to go ahead and click File, and I can save it over. And then I can go back to my command line. Since I'm already in desktop, the location of my file, right, I'm going to go ahead and recompile the sound.java file as I edited it. And it successfully compiled. If it has an error, make sure you go in and fix the error, resave, and recompile. Now I'm going to go ahead and run the program by doing Java sound with no file extension there. And again, we are receiving the same output. So as you can see, you can also assign additional variable to hold the values and use the arithmetic operator to provide the same output. And I see some of this being done by quite a few students in the class in Unit 1 as you completed the Unit 1 assignment 6, 7, and 8. But this is just a basic for those of you who are new to programming and also Java programming. So you can actually allocate, right, create additional variable. And here I'm using the comma to separate multiple variable declaration. So basically it's saying that I have this variable originally, right, and it holds double data type, right? It can hold the larger value. And then time variable, right, that's also double data type. And then rate variable, that's also double data type. So if you have the same data type, you can keep them all in one line and use the comma to separate them and finish that out with a semicolon. And then down here, once I declare the variable, I can go ahead and assign it the value. So time, we tell it it's 7.2 seconds, and then rate is 1100. And so here, lastly, we stated that this variable is time variable times rate variable, and it's still going to give you the same output.